Good morning everyone. In the previous lecture we have discussed about the different kinds of matter on the basis of physical properties and on the basis of chemical properties. Now in today's lecture we will discuss about the properties of matter. We know that each and every substance is having certain kind of properties. Now we can distinguish them on the basis of physical properties and on the basis of chemical properties. Now what are physical properties? Physical properties can be judged without changing the identity of an original substance. That means if we are having any of the substance, so we can say its color is this, its density is this. So in that case we are not changing the identity of that substance. So these are called physical properties. For example, color. If we are seeing a pencil box, so we can easily say that okay, this pencil box is of red color. Okay, if we say any of the substance, we say oh, its melting point is this, its boiling point is this. It is when we put it in water, we say it sinks, that means its density is more than water. In that case, these are some of the properties which we can only see by without changing the identity of that substance. That is its color, melting point, boiling point, density. Now there are some of the properties which needs a chemical reaction. That means they are called chemical properties. For example, if we have to check whether a particular substance is acid or base, or about its combustibility, in that case we require a chemical reaction. In that case we can say that physical properties does not require any chemical reactions, and in case of chemical properties it requires a chemical reaction to occur. Now there are some of the properties which are quantitative in nature, which requires some value along with its unit. For example, we are writing length of a room, so we can write for example 5 meter. So in that case 5 is its quantity and meter is SI unit. So for that there is an organization which is General Conference on Weight and Measure, which gives certain units for certain quantitative properties that are known as SI units. It is called International System of Units. There are 7 base units for different quantitative properties, which are as follows. Now see the 7 base units. These are base physical quantities. This is symbol. This is name of SI unit and this is the symbol of SI unit. First physical quantity is length. Its symbol is L. Name of the SI unit, the length is measured in meter and the symbol of SI unit is small m. Similarly for mass, it is m. Its SI unit is kilogram and it is kg. For time, we measure it in second. Its SI unit is second. Similarly, electric current, it is denoted by I and its SI unit is ampere. Temperature is always measured in Kelvin. Amount of a substance, it is measured in mole, and luminous intensity, it is measured in candela. So these are the 7 base units. Understood? Now students, see the different prefixes that we use in SI unit. For 10 to the power 1 we use the prefix deca. For 10 to the power 2 we use the prefix hecto. For 10 to the power 3 we use the prefix kilo. For 10 to the power 6 we use the prefix mega. For 10 to the power 9 we use giga. For 10 to the power 12 we use tera. For 10 to the power 15 we use peta. 10 to the power 18 we use the prefix exa. For 10 to the power 21 we use the prefix zeta. And for 10 to the power 24 we use the prefix iota. Similarly, come on this side. For 10 to the power minus 1 we use deci. 10 to the power minus 2 we use centi. 10 to the power minus 3 we use milli. 10 to the power minus 6 we use micro. 10 to the power minus 9 we use the prefix nano. 10 to the power minus 12 we use the prefix pico. 10 to the power minus 15 we use the prefix femto. 10 to the power minus 18 atto. 10 to the power minus 21 we use zepto. And 10 to the power minus 24 we use the prefix yocto. These are the different prefixes which we use in SI unit during the conversion of one unit into another unit. Now students, see the difference between mass and weight. What is mass? Mass is the amount of matter present in any of the substance, that is called mass. And what is weight? The force that is exerted by gravity on any of the object, that is known as its weight. Right? The SI unit of mass is kilogram and the SI unit of weight is same as the SI unit of force, that is Newton. Now in case of mass remains constant at each and every part of the universe, but in case of weight it changes according to gravity. Understood? Now students, see the next topic, that is density. What is the density? The density means mass per unit volume of a substance is known as density. That means if we have to write a unit of density, what we will write? Then unit of density is equal to unit of mass upon unit of volume. Mass per unit volume of a substance is called density. Now unit of mass is kilogram and unit of volume is meter cube. We can write kilogram per meter cube. But it is a larger unit. Sometimes for a small quantity we use the unit of density as gram per centimeter cube. Understood? The density of water is 1 gram per centimeter cube. If any of the substance sink in water, that means its density is more than water, and if any of the substance float on water, that means its density is less than water. Understood? Now students, see the next topic, that is temperature. There are different scales to measure the temperature. First is Celsius scale, second is Fahrenheit scale, and third is Kelvin scale. Kelvin scale is also known as thermodynamic scale. The SI unit of temperature is Kelvin. Now we can convert one scale into another scale by using these formulas. We can convert degree Celsius into Kelvin by using this formula. K is equal to degree Celsius plus 273.15. Similarly, we can convert degree Celsius into degree Fahrenheit by using the formula degree Fahrenheit is equal to 9.5 degree Celsius plus 32. Similarly, we can convert Fahrenheit into Celsius by using this formula degree Celsius is equal to 5/9 in bracket degree Fahrenheit minus 32. By using this formulas, we can convert one unit into another unit. Understood?